the assertion that humanity is fundamentally composed of star stuff, a concept famously popularized by astronomer and science communicator Carl Sagan, is not merely a poetic metaphor, but a literal, quantifiable biochemical reality. The cosmos and human biology are inextricably linked by a 13.8 billion-year lineage of stellar nucleosynthesis, galactic chemical evolution, and planetary accretion. Every atom within the human body, barring primordial hydrogen and lithium, was forged in the extreme thermodynamic crucibles of stellar cores, the cataclysmic detonations of supernovae, or the violent mergers of ultra-dense stellar remnants known as kilonovae. The transition from a primordial universe dominated by light elemental gases to a chemically complex cosmos capable of supporting advanced biological entities relies entirely on these astrophysical engines. The elemental architecture of the human body. The human body is a highly ordered homeostatic matrix of billions of atoms, representing a remarkably selective cross-section of the periodic table. While the observable universe is predominantly composed of hydrogen and helium, terrestrial biology has selected specific elements based on their valency, solubility, redox potential, and capacity for complex covalent bonding. The elemental composition of the human body is traditionally categorized into primary elements, minor essential elements, and trace elements, each playing distinct structural, metabolic, and regulatory roles. Minor essential elements. Another 5 elements make up approximately 0.85% of the remaining human body mass: potassium, sulfur, sodium, chlorine, and magnesium. These elements function primarily as systemic electrolytes, osmotic regulators, and structural cofactors. Potassium 0.20% to 0.4%, approximately 140 gram, operates as the primary intracellular cation, working in strict opposition to sodium 0.2, chlorine 0.14% to 0.2%, approximately 100 gram, operates as the primary extracellular anion, functioning in tandem with sodium to maintain systemic osmotic balance, blood volume, and the generation of hydrochloric acid in the gastric mucosa. Sulfur 0.20% to 0.3%, approximately 140 gram, is required for the synthesis of the amino acids cysteine and methionine. Magnesium 0.1%, though the least massive of the 11 non-trace elements, is an obligate cofactor for over 300 enzymatic reactions. Trace elements and their disproportionate biological impact. The remaining fraction of the human body, less than 0.15% by mass, or under 10 grams in total, is composed of trace elements. Despite their minuscule concentrations, these elements are absolutely indispensable for life. They function almost exclusively as catalytic cofactors for oxidoreductase enzymes, maintain redox equilibrium, modulate immune responses, and regulate complex hormonal signaling cascades.